Hello, today we are discussing about AC amplifier using operational amplifier. So op-amp based AC amplifier we are going to study. You may get a doubt that whenever op-amp is going to amplify both AC and DC signal, why we are going to study about AC amplifier? Because there will be some applications where the output of those some blocks are going to be only consisting of a range of frequencies which doesn't consisting of DC component or low frequency components. By that time the operational amplifier has to amplify only AC components present at the input side. You can think it is a situation like this. For example, we are going with a CE amplifier. The output of CE amplifier is common emitter amplifier which amplifies a range of frequencies. The frequencies will be specified with the bandwidth, okay, and generally we are going with a frequency response curve which is going to be specifying what range of frequencies will be amplified by the maximum gain. So this is frequency response of CE amplifier where it is going to be FL and FH. So first of all you have to identify the maximum gain, and by that time take 1 by root 2 of that one, that is divide that maximum gain by root 2 and get a vertical line on gain scale. Then you are going to be getting 2 points, okay, one on the left side that is nothing but FL, one on the right side that is FH. So FL, FH are going to be lower and upper cutoff frequencies of the amplifier, okay. So within this frequency range the amplifier amplifies the signals properly. Now you see, CE amplifier doesn't amplify the DC signal as well as low frequencies up to FL, and above that one all frequencies are going to be amplified till FH, and above FH no frequencies are going to be amplified properly. If the gain provided by the CE amplifier is not sufficient, by that time you are going to be applying the output of the CE amplifier to the operational amplifier. Now op-amp based amplifier. So by that time this operational amplifier now has to amplify only the frequency range provided by CE amplifier. It should not amplify the DC as well as low frequency signals, okay. So everywhere some noise will be present, okay, and as well as a DC component if it is inserting at the time that should be blocked. So AC amplifier is nothing but specifically, okay, the main application of this one is nothing but it blocks DC component, blocks DC and low frequency component. The meaning of this one, low frequency components. AC amplifier based op-amp implies nothing but which blocks DC component as well as low frequency component. If you are looking at this definition, this is nothing but it's a definition for high pass filter. It's a definition of high pass filter. So in simple words, AC amplifier is going to be act as high pass filter, okay, with its lower cutoff frequency as FL and upper cutoff frequency is nothing but infinite. So now the op-amp should have the characteristics like this. It should amplify only the frequencies from FL and FH is not defined. This is what FL. So this is frequency response of op-amp such that it is blocking the DC component until low frequency component, and above that one all the frequencies are passed. So in this frequency range you will get this FH also. So output of CE amplifier is also passed through this operational amplifier, and that will be providing required gain. Now we will see what are the different types of AC amplifiers are going to be available, okay, and how to realize them. What is the expression for that one, okay, how to define the lower cutoff frequency. So simply remember, AC amplifier is nothing but high pass filter with a lower cutoff frequency, that is FL, okay. So now there are three versions are there. Two are going to be required as amplifiers, the other is nothing but voltage follower. So these are the three cases we are going to study under AC amplifier. One is inverting AC amplifier, second one is non-inverting AC amplifier, third one is AC voltage follower, okay. Here 1 and 2 are going to be AC amplifiers only, but whether your input is applying across non-inverting input or inverting input, based on that one there will be two cases: inverting AC amplifier, non-inverting AC amplifier. Okay, so first we will study about inverting AC amplifier. So this is inverting AC amplifier circuit diagram, as it is mentioning it as inverting AC amplifier, that is AC amplifier made up of op amp in inverting mode. In inverting mode, input signal is applied to inverting terminal and non-inverting terminal kept at ground. So that is what you can observe here. Input signal is applied to inverting terminal through R and C network, and output, that is non-inverting terminal, is kept at ground. Okay, so now look at this one. Can we say that one, this configuration is nothing but high pass filter? Okay, so if you are going with, look at this, it is very important. Generally if you are going with up to this point only, if you look at, that is nothing but this is the block. If you are going for this circuit at that time, can we say that one, it is inverting op amp, inverting mode op amp? Can we say this one? For inverting mode op amp, the input signal is applied across this point, okay, and the non-inverting terminal is going to be kept at ground. So this is inverting mode op amp. For example, let us assume the voltage at this point. Voltage at this point is V1 or something as Vx. So you can write V0 is equal to, by using inverting op amp, minus Rf divided by R1 times of Vx. This is what the gain equation, where Vx is equal to, how do you define Vx? Vx is nothing but from that node towards ground. Because of op amp, it is going to be having infinite gain, and so that there will be a virtual short concept will be there. That implies nothing but voltage at both terminals are going to be same, that is at inverting and non-inverting terminals are going to be same. Okay, this concept is going to be arising from this fact. We know that one open loop gain AOL is equal to infinite for ideal op amp. Ideal op amp, for ideal op amp, open loop gain is infinite, and open loop gain is nothing but, it can be defined in this way: V0 divided by VID, output voltage divided by the input difference signal. So from this one you can write it as VID is equal to V0 divided by AOL. So VID is equal to V0, whatever the output voltage, divided by infinite gain. Something by infinite is 0, and VID is nothing but input difference voltage, that is difference between voltage at non-inverting terminal and voltage at inverting terminal. So from this one we can say V plus is equal to V minus. This is only possible. That implies nothing but this concept is going to be called as virtual short. Because of virtual short concept, voltage at non-inverting terminal and inverting terminal are always same. If you know the voltage at inverting terminal, you can say what is the voltage at non-inverting terminal, vice versa. So that because of this one, since non-inverting terminal is at ground, so inverting terminal is also at ground node, that is nothing but 0 volts. So Vx you can draw in this way, Vx can be drawn in this way. So this is what R1 and it is C, where you are going to be applying V input, Vi from plus minus, and Vx is nothing but voltage drop across R1. Okay, so now this is a simple high pass filter. Output of high pass filter is Vx, that is going to be applied for the inverting op amp mode. So you are going to get V0 is equal to minus Rf by R1 times of output of high pass filter. This is what the transfer function. So theoretically the transfer function is nothing but V0 is equal to Rf by R minus Rf by R1 times into output of high pass filter. So if you are simply going with high pass filter with RC components, at that time gain provided by that one is at most 1, but you can provide more gain for the input signal by passing it through an op amp. then it is going to be called as inverting AC amplifier. Okay, we will see how to define the cutoff frequencies for this one. Okay, so Vx can be written as V0 is equal to minus Rf by R1 times of Vx. Vx already we know Vx from the voltage division rule from this diagram. Okay, minus Rf by R1 into R1 divided by R1 plus 1 by j omega c. This is what you can write. Xc is nothing but reactance of capacitance, that is nothing but 1 by j omega c, and if you take R1 common, you are going to get it as minus Rf by R1 minus Rf by R1 times of, if you take R1 common from the denominator, at the time R1 get cancels, you will get it as 1 by 1 plus 1 by j omega rc you will get. So from this one, minus Rf by R1, which is nothing but gain of inverting mode op amp, 1 by 1 minus j. 1 by j you can write it as 1 minus j. Omega is nothing but 2 pi f. So the 2 pi f rc, except that f, the above thing can be treated as fl. So this is what you can write. So this is transfer function of high pass filter. It's a transfer function of it's a transfer function of high pass filter with lower cutoff frequency as fl, whose value is nothing but 1 by 2 pi r1 into c. This is r1. Okay, 1 by 2 pi r1 into c. So by choosing the component values for r1 as well as c, you can define the lower cutoff frequency, so that this is going to be acting as AC amplifier, which passes the frequencies from that frequency onwards. All above frequencies are going to be passed and below frequencies are going to be suppressed. Okay, so we can also see this one with the help of gain also. Okay, so this is what gain for this one. This is AV, voltage gain. V0 into this, you can write it as V input. So V0 by V input is nothing but gain. V0 by V input, that is transfer function. Transfer function is nothing but gain. From this gain, if you are going with magnitude, at that time you will get this equation. So this is the diagram and this is the equation. Gain transfer function AV is equal to V0 divided by Vin, which is nothing but minus Rf by R1 times of 1 minus j FL by F. So if you are going for the only gain, at that time you can write it as minus Rf by R1 into 1 by into 1 by square root of 1 plus FL by F whole square. You will get this one. So from this one, if F is going to be less than FL, F implies nothing but, remember this one, this is input signal frequency. Input signal frequency. So if your input signal frequency is lesser than lower cutoff frequency, by that time the gain provided AV is equal to minus Rf by R1 into 1 by square root of FL by Fs is going to be very large. So 1 by very large, you can think it as 0, very small. So this will be very small, because Why it is going to be very small? Since FL is large, FL by F whole square is going to be very large compared to 1. By that time 1 by very large you will get. This square and square root will get cancels. 1 by FL by F by FL you will get now. Overall that F by FL is going to be very small. Whenever it is multiplying with gain also, what you will get is very small. So we will assume in this way. And if F is going to be greater than FL, at that time FL by F and whose whole square is going to be very far less than 1. So that simply it is AV is equal to, you will get it as, this term will be neglected. By that time you are going to be getting the maximum gain as minus RF by R1. So for the signals greater than FL, the gain provided by this amplifier is minus RF by R1, and for the signals less than FL, gain provided is very small, such that it acts as AC amplifier. AC amplifier which is passing all the frequencies from FL. Okay. So this is high pass filter, output of high pass filter. You are connecting it to inverting mode op amp, such that it is going to be acting as inverting mode AC amplifier. Now we will see non-inverting mode AC amplifier. Non-inverting mode AC amplifier is nothing but simply you are connecting output of high pass filter to the non-inverting op amp. So this is what the circuit diagram. Here output of high pass filter should be connected to input of non-inverting op amp. Input of non-inverting op amp is nothing but this one. This is the input of inverting non-inverting op amp. So this is, for example, it is Vx. So this is, it act as high pass filter, and high pass filter, output of high pass filter is nothing but Vx, that is going to be connected to the non-inverting mode, non-inverting terminal. So it is acting as non-inverting op amp. From this one it is called as op amp non-inverting mode op amp. Non-inverting mode, non-inverting mode op amp. So that we know that one, for non-inverting mode op amp, the gain provided by the amplifier is 1 by RF by R1 times 1 by RF by R1 times for the voltage, effective voltage available at non-inverting terminal. So at this non-inverting terminal, what is the voltage you will get? That will be multiplied by 1 plus RF by R1. So you can write it as V plus. So V0 is equal to 1 plus RF divided by R1 times of V plus. V plus implies nothing but voltage at non-inverting terminal, that is nothing but Vx. So you can write like this. Vx is nothing but, again it is you can write it as 1 plus V0 is equal to 1 plus RF by R1. It is simply output of half wave rectifier. Already have seen how to write the equation and expression. That will be same as like this, 1 by J FL by F. This is what you can write into V input. So AV, voltage gain for this one, is V0 divided by V input is equal to 1 plus RF by R1, which is nothing but gain provided by non-inverting op amp for the output of high pass filter, 1 minus J FL divided by F, where FL is equal to, for this one FL is equal to 1 by 2 pi R2 into C1. Look at this one, this is R2, this is a combination we are going with C1 R2. So that this is 1 by 2 pi R2 into C1 is nothing but lower cutoff frequency. So again the same thing. Okay, for this function at that time, if the frequency is going to be, if frequency is less than FL, at that time the gain provided by this one is very small, very small. If F is going to be greater than FL, at that time the gain provided is going to be approximately equal to 1 plus RF by R1. So again it is going to be acting as AC amplifier. AC amplifier with non-inverting mode, so that it is called as non-inverting AC amplifier. Next we are going for the AC voltage follower. Sorry, one more, it has one disadvantage. Okay, so it has one disadvantage that we will discuss, and how to rectify that one also we will see. So disadvantage of this non-inverting op amp. Disadvantage of non-inverting op amp. Generally we know Ri of non-inverting op amp is infinite, but whenever you are applying input for the non-inverting terminal at that time, okay, for this circuit Ri is nothing but effective input impedance looking into the input. So this is what you are going to see. If you are looking at over here at that time, this is Ri. So Ri value for this one is going to be for different cases. Whenever it is the frequency is less than FL, frequency is greater than FL, Ri value will change. Okay, since the current is flowing in this way, the current is flowing in this direction, because no current flows into the op amp input terminals, so that the effective impedance is nothing but series combination of R2 and reactance of C1. So this is when the frequency is small. When the frequency is large, at that time capacitor act as short circuit, so that only R2 will be the input resistance. So Ri effective, okay, is going to be XC2 XC1 plus R2 when F is less than FL, and effective input impedance is going to be simply R2 whenever F is greater than FL, because for the frequency is greater than lower cutoff frequency, capacitor act as short circuit. Okay, such that you are going to be getting the input signal is multiplied by 1 plus Rf by R1 times. Next, so the disadvantage is nothing but input impedance is going to be reducing. Generally non-inverting mode is preferred since it is having very high input impedance. Okay, but that advantage is going to be getting eliminated. So how to remove this disadvantage? For that one we are going with a different circuit. Okay, so how to eliminate the disadvantage provided by this one? So if you look at the previous circuit and this circuit, just extra C3 capacitor is added, and R2 previously it was connected ground, now it is connected at the end of C3. So that way I am assuming that one it is node N. Okay, so input signal is as it is applied, output of high pass filter is applied as input to the non-inverting input, and the R2 is not connected to ground, it is connected to the, this is the node where C3 and R1 is going to be joined. This C3 is going to be connected extra. Okay, now we will see how can we say that one input impedance for this one is going to be improved. Okay, so this capacitor C1 and C3, the assumption C1 and C3 are going to be acts as open circuit. C1 and C3 acts as open circuit for frequencies less than FL. For frequencies less than lower cutoff frequency, capacitors C1 and C3 are open circuit, so that simply it is going to be, it act as open circuit, this also act as open circuit. That implies nothing but, okay, V input is not going to be applying to op amp. Whenever Vi is going to be not going to applying to op amp, at that time output will be 0. It no more depends on input signal. So output is independent of input. Output is independent of input. Okay, that is nothing but V0 is equal to 0 even Vin is applied. So the input signal is suppressed. The meaning is nothing but it is blocking the input signal. So the DC component as well as low frequencies till FL are going to be blocked by this one, because the capacitors act as open circuits. Now the capacitors are going to be act as C1 and C3 acts as short circuit. C1 and C3 are act as short circuit for F greater than FL. Okay, we will choose the values of C1 and C3 such that they will be acting as short circuit for the frequencies greater than FL. They will be acting as open circuit for the frequencies less than FL. So whenever they are acting as short circuit, at that time we can check about this circuit. Whenever they are acting as short circuit, at that time this will be now a simple wire can be replaced, a short circuit, and here also there will be a short circuit. So this is also replaced with a wire. Short implies nothing but it's going to be a simple wire. So C1 act as short circuit and C3 is also acting as short circuit. Now look at this node N and inverting terminal, both are at the same voltage, and since because C3 is acting as short circuit, because of that one node N and inverting terminal are going to be at same node. Okay, and because of virtual short concept, you will get the same voltage at the, that is same voltage will be present at inverting and non-inverting terminals. So look at this one. If VI is going to be the input voltage, and because C1 is acting as short circuit, you will get the voltage at non-inverting terminal as VI. And because of virtual short concept, the non-inverting terminal voltage will also be present at inverting terminal voltage. So that is also VI. And inverting terminal and this node N are also at the same voltage, which implies nothing but it will be also VI, because C3 is acting as short circuit. Now if you check, the both ends of R2 are going to be at VI or not? Now if you observe, okay, both ends of R2 are at VI. So voltage drop across R2 is equal to 0. VI minus VI, voltage difference, that is voltage drop across R2 is 0. Voltage drop across R2 can be seen as, okay, voltage drop is nothing but something, current flowing through that resistor multiplying by that resistor. Okay, current flowing through that one, I am assuming it as I. So that I into R2 is nothing but voltage drop, but R2 is having some value, so definitely this makes I to become 0. So this makes forcefully I becomes 0. So ideally the current flowing through R2 is going to be 0, because whenever the capacitors are acting as short circuit, it is present between inverting and non-inverting terminals. Okay, across that one virtual short is going to be existing, that forces the voltage across R2 to become 0. That makes current flowing through R2 is becoming 0. Now if you are going to check about input resistance, effective input resistance looking into, okay, looking from input side, at that time this is what you are going to get. Effective input resistance is nothing but now this point. You are looking from this one, Ri. Ri is equal to Vi divided by current flowing through this one. So the same current is also flows through this one. Same I is also flowing in this direction. So that Vi divided by 0, which is nothing but infinite. It is ideally. Practically this will be very, very large. So the previous circuit is having disadvantage of effective input impedance is going to be reducing, and now the effective input impedance is going to be increases, and it is also acting as high pass filter. That is nothing but it acts as AC amplifier with very high input impedance. Now the third circuit we are discussing is nothing but AC voltage follower. The meaning of AC voltage follower is nothing but same as AC amplifier with unity gain. Previously those circuits are providing gain, but now the gain provided for this one is nothing but 1. So the characteristics of voltage follower is nothing but AV is equal to 1, voltage gain has to be 1, and Ri, input impedance, is going to be infinite, R0, output impedance, has to be 0. So simply we can tell like this: voltage follower is nothing but is an ideal voltage amplifier. Ideal voltage amplifier with unity gain. Voltage follower is nothing but ideal voltage amplifier with unity gain. So gain is going to be 1, but all other characteristics are going to be same with respect to ideal voltage amplifier. Now AC amplifier with unity gain is going to be called as AC voltage follower. If you are not mentioning AC, by that time simply if you call voltage follower, by that time that passes all DC components, that passes DC component, low frequencies, high frequencies, all the frequency components including DC will be passed through that voltage follower. But here we are only interested in the AC voltage follower, that is it has to pass the frequencies from FL. So this is what the frequency response for us. So only from FL onwards the frequencies above FL has to be passed through this voltage amplifier, and the below this one has to be stopped. So you can say it is going to be stop range and pass range. So this is going to be called as stop band and it is pass band for AC voltage follower with gain as going to be 1. So this is frequency response of AC voltage amplifier. Again it is same as high pass filter, okay, but the gain providing is nothing but 1. And the advantage of this one is nothing but it will not load the input impedance of next stage, whereas if you use directly RC network which is acting as high pass filter, that will load the next stage. But now this circuit will not load the next stage because of voltage follower. That is the advantage. Now we will see how this circuit is acting as voltage follower, how it is stopping the frequencies below FL, how it is passing the frequencies above FL. Okay, so assume that one for F less than FL, that is for the frequencies below lower cutoff frequencies C1 and C2 acts as open circuit. Whenever they are acting as open circuit, at that time this is acting as open circuit, this is also not there, so it is also acting as open circuit. That implies nothing but Vy, input is not going to be connecting towards output. Input is not going to connect to op amp input, that is nothing but output of op amp doesn't depend on the input signal. So V0 is equal to 0. Even Vi is applied. Even Vi is going to be present, but the frequencies are going to be less than FL, so that is not applied to the op amp, so that output of op amp is not depending on Vi, which implies nothing but all the frequencies till FL are going to be suppressed by this circuit. So V0 is equal to 0 for Vi with frequencies up to FL. Okay, now we will see what happens when the frequency is greater than FL. So this is what the circuit AC voltage follower, and assume C1 and C2 acts as short circuit for frequencies greater than FL. So whenever they are acting as short circuit, simply you are making, that is C is replaced with a wire. C is replaced with a wire. Short circuit is nothing but wire, so that you are replacing C1 and C2s with a wire, which we are mentioning it as short circuit. By that time the effective circuit is going to be looking like this. This is the effective circuit. R2, it is R1, and this is V1, Vi, and it is V0. This is minus and it is plus. So that now because of virtual short, now what you are going to get is, because of virtual short, voltage at non-inverting and inverting terminals are same. Non-inverting terminal is directly connected to Vi, so that inverting terminal is also at Vi, which is nothing but it is shorted to output node, so that V0 is equal to Vi. V0 is equal to Vi, that is nothing but now it is acting as voltage follower, okay, for the frequencies above FL. But what happens to the input impedance, whether the input impedance is very high or not, that you have to check. So that this node is Vi, and for this R1 the other end is going to be connected towards output, so this is nothing but V0. Since C2 is going to be acting as short circuit, that is making R1 resistor to act as feedback resistor. Since C2 is acting as short circuit, that makes R1 to become feedback resistor, because now R1 is between input node and output node, so it will become feedback resistor. Whenever R1 is going to be connected between input and output, at that time that can be replaced, and that can be written separately at the input side as well as output side using Miller's theorem. Okay, by that time if you are going to check the equivalent circuit, so it will be looks like this one. This is what the op amp circuit, okay, with unity feedback, and now we are going to draw the output side resistances separately, input side resistances separately. This is what Vi, and it is V0. This is plus and it is minus. Okay, now see, input side is going to be connected with only R1, and R1 is a feedback resistor, so it has to be replaced with a resistor value of R1 divided by 1 minus ACL, that is nothing but closed loop gain. And at output node, this is output node, from this output node R2 is connected to ground, so that we will connect R2 directly towards ground, and R1 is nothing but it is a feedback resistor that has to be equivalently represented output side. By that time it will become R1 divided by 1 minus 1 by A. Okay, so 1 by ACL. If you are going for effective input impedance over here, Ri, effective input impedance, Ri is going to be equal to R1 divided by 1 minus ACL. ACL is nothing but closed loop gain. Closed loop gain of voltage follower is nothing but output voltage by input voltage, but output voltage is same as input voltage, so that it is approximately equal to 1. So now Ri will become, Ri is equal to R1 divided by 1 minus 1, which is nothing but R1 by 0, which is approximately infinite. So it is providing very high input impedance. Along with unity gain for the frequencies above FL. So it perfectly acts as AC voltage follower, which is blocking the frequencies up to FL and which is passing the frequencies above FL. Thank you.